Moving on to our next topic, two more states of matter. Apart from solid, liquid, and gaseous state, there are two more states of matter. The first one is called plasma state. About 90% of the matter in the entire universe is actually in plasma state, and this state exists at very high temperature only. Plasma state is found at a very high temperature. In this state of matter, matter has positive ions and free electrons. There are positive ions and there are free electrons. For example, if we take an element sodium, it has electrons around the nucleus. So when we heat it, on heating, the electron from its large shell comes out and it becomes a positive ion. So whenever a matter is heated, when there's a high temperature, we will get positive ion and electrons. So mixture of positive ions and electrons when we have, that means that matter is in a plasma state. Example, neon sign bulbs, which are used for advertisements, and then fluorescent tubes, shiny tubes. In these appliances, matter exists in plasma state when we are using them. Coming to the next state of matter, Bose-Einstein condensate, abbreviated as BEC, Bose-Einstein condensate. On the basis of calculations made by an Indian physicist, S.N. Bose, he made some calculations. On the basis of the calculations made by S.N. Bose, Albert Einstein predicted the possibility of this fifth state of matter called Bose-Einstein condensate, after the name of the scientist, Bose-Einstein condensate. S.N. Bose made some calculations, and on the basis of these calculations, Einstein predicted this fifth state of matter, and later on this state of matter was achieved by American scientists. In the Bose-Einstein condensate, this is formed when gas, like suppose these are gas particles which are quite away from each other, when they are cooled to a super low temperature around minus 273 degrees Celsius, close to this temperature. This temperature is called absolute zero temperature, minus 273. In fact, it is minus 273.15. Exact is minus 273.15 degrees Celsius. This temperature is called absolute zero temperature. So when gases are super cooled to a low temperature close to this absolute zero, then what will happen to these gas atoms? They will start combining with each other. They will begin to clump. When they will combine, then super atoms, big size atoms, they will start forming. Big size atoms, they will start forming up here. And this state is known as Bose-Einstein condensate. Condensate means they are condensing. Condensing means these are coming close to each other and forming super atoms, very big size atoms. So this is the fifth state of matter called Bose-Einstein condensate. Example of this is liquid helium near to this absolute zero temperature exists in this fifth state of matter. Liquid helium near absolute temperature exists in this fifth state of matter. So these are two more states of matter, plasma state and Bose-Einstein condensate. Moving on to the next topic, temperature. What is temperature? It is a measure of degree of hotness or coldness of a body. If we have to tell how hot is this body or how cold is this body, we tell that in terms of temperature. So hotness and coldness, they are measured in terms of temperature. Temperature measurement has different scales. There are different scales for expressing temperature. These scales are, first one, Celsius scale, written as degree Celsius. Degree Celsius. In this scale of temperature, the thermometers which are designed, the lowest value here in this thermometer and the highest value here in this thermometer is based on freezing point of water and boiling point of water. The thermometer with Celsius scale, they are calibrated between 0 degree Celsius, that is freezing point of water, and 100 degree Celsius, that is boiling point of water. And between 0 to 100, these have 100 small divisions. Every division is equal to 1 degree Celsius. So this is how we get the degree Celsius or the Celsius scale thermometers. Second is Fahrenheit scale. In this scale, again the lowest temperature here is 32 Fahrenheit and the highest one is 212 degree Fahrenheit. 32 degree Fahrenheit is the freezing point of water, while 212 degree Fahrenheit is the boiling point of water. So we can say 0 degree Celsius is equal to 32 degree Fahrenheit and 100 degree Celsius is equal to 212 degree Fahrenheit. And if we want to change degree Celsius temperature to the Fahrenheit temperature or the Fahrenheit to the degree Celsius temperature, the two scales are related with this formula. Degree Fahrenheit temperature is equal to 9/5 degree Celsius plus 32. So using this formula, we can interchange degree Celsius temperature to Fahrenheit, Fahrenheit to degree Celsius. The third scale is Kelvin scale. This is also called absolute scale. And in this scale, the lowest point again is the freezing point of water, and that is taken as 273 Kelvin, and the highest one is 373 Kelvin, that is the boiling point of water. The Celsius and the Kelvin scale, they are interconverted using this formula. Kelvin temperature is equal to degree Celsius plus 273. Since 0 degree Celsius is equal to 273. So degree Celsius temperature, if we add 273, that will change to the Kelvin temperature. So this is about our topic temperature. What is temperature and how temperature is measured using Celsius scale, Fahrenheit scale and Kelvin scale. Next topic, change in state of matter. How we can change the state of matter, solid to liquid, liquid to gas, etc. There are two ways to achieve this: by changing temperature, by changing pressure. By changing temperature and by changing pressure. So today we are doing the first way here, that is by changing of temperature only. Effect of change of temperature. When temperature is changed, what will happen to the state of matter? First example we are taking here is of change of state from solid to liquid. Just changing the solid to liquid. What happens when we change the solid to the liquid? Solid particles, we know, are very close to each other. They are packed close to each other, and between the particles there are strong attractive forces and very small interparticle spaces are there. So when this solid is heated, when we heat this solid, the interparticle attractive forces between these particles, the attractive forces, they will break. And if the attractive forces will break, then the particles, they will move. When particles are moving, they will move away from each other, and hence the interparticular space will increase and forces between these particles, they will be weak now. When the particles are moving away, a state will come when this solid changes to liquid. The particles are so away that from solid they have changed to a liquid state. So when we increase the temperature, change of temperature means when we are increasing the temperature here, solid will change to the liquid state. And the temperature at which the solid is changing to the liquid state, that temperature is known as melting point. That is called melting point. And this change of state from solid to liquid is called melting. This process is called melting, or this is known as fusion. Melting point of ice. If we take ice, we know melting point of ice is 0 degrees Celsius. In Kelvin, when we take 273 Kelvin, exact is 273.15 Kelvin. This is the melting point of ice. Now one experiment to study the melting of ice. To study the melting of ice. For melting of ice, we are taking a beaker. In this beaker, we will take crushed ice. We'll pack this with the crushed ice. Beaker is of 250 ml capacity and approximately 150 gram. How much ice we are taking into this? 150 gram of crushed ice we will take in this. And in this we have to suspend a thermometer. this bulb of thermometer should be there in an ice. So this we are suspending into this. And now we have to heat this ice. So when we are heating this ice with the help of burner, then what will happen? A state will come when this ice will just start melting. Note down that temperature when ice will just start melting. Continue heating it and keep observing the temperature. Note the temperature when whole of ice has just melted. So we have to note down the two temperatures here. First, when the ice will just start melting, and second time we have to note the temperature when whole of ice has just melted. This is experiment. Observations. What we will observe? Once the melting starts, the temperature does not change after that till whole of ice will melt. When ice will start melting, the temperature is 0 degree Celsius. Now we are heating it still till whole of ice will melt. When the whole of ice will melt, see the temperature. Again we find a temperature is 0 degree Celsius. Though after just the melting of ice started, we are heating it. We are continuously heating it for whole of the ice to melt. But still the temperature is not increasing though we are providing heat to it. Latent heat of fusion will give us the answer for this. Answer lies in this term, latent heat of fusion. Why the temperature is not increasing once the ice has started melting till the whole of ice will melt? Why temperature is not increasing in the thermometer though we are heating it? Continuous heating is supplied though temperature is not increasing. So where does this heat energy go? Latent heat of fusion. It is interesting to note that when the solid melts, just starts melting, at its melting point, it changes to liquid. The heat energy that we are giving to this is used in changing the state from solid to liquid. That energy is used to break the forces of attraction between the particles, and with that they move away. Since this energy heat is not increasing the temperature of solid, this is hidden heat. That is why it is called latent heat of fusion. So to understand this, let's say this is a solid state. Particles are close to each other like this. So we are heating this solid. When we heat, suppose some of the particle, like this particle, the force is breaking, it will move little away. From here, this will come here. So this much of distance is there between these two particles now. So from here, the solid has changed to liquid at some temperature called melting point. After this, we are still heating it. So where that heat is going, that is breaking up the forces between these particles so that they should also move away and they should also change from solid to liquid state. So that heat is not increasing the temperature of these particles. That heat is actually used up in breaking the forces between these particles. That is why it is not shown by thermometer. So this is hidden. That is why this is called latent heat of fusion. Latent heat of fusion, the definition is amount of heat. This is the amount of heat required to convert 1 kg of solid, 1 kg of solid to liquid at its melting point. At its melting point, the amount of heat required to convert 1 kg of solid to liquid at its melting point is known as latent heat of fusion. So this is about the change of the solid to the liquid state. Example is melting of ice. Next, in change of temperature, we are taking change of state from liquid to gas now. When liquid changes to gas. So when liquid is heated, now again to understand, suppose these are liquid particles. They are so away from each other like this. This is a liquid state. And when we heat it, again the forces between these particles, though these are very weak, but still there are forces of attraction, they will start breaking. These forces will break. And after this, the particles are free to go away from each other. When particles will be away from each other, then they are changing to which state? Gaseous state. This is liquid and this is the gaseous state. Now the temperature, how much heat we have to give to change this liquid to gaseous state. The temperature at which the liquid will just start changing to the gaseous state is called boiling temperature. The temperature is called boiling temperature. And this process of changing liquid to gas is known as vaporization. And boiling temperature, boiling point of water is 100 degrees Celsius, or in Kelvin we'll say 373 Kelvin. Now one experiment to study the boiling of water. To study the boiling of water. Now for this we are taking a beaker. In this beaker we are taking water. In 250 ml beaker, suppose we are taking 150 ml of water. And then we have to suspend a thermometer here. We have to suspend a thermometer here in this. Its bulb of thermometer should dip into the water. And we have to heat it now. So water, thermometer is here, and when we'll heat this water, we have to see at which temperature the water will start changing to the vapor form. Just start changing to the vapor form. That temperature we have to note down. That temperature is called boiling point. When liquid just start changing to the vapor form. After this we have to still heat it to change whole of this liquid to the vapor state. Note down the temperature. But we'll find again here, like in solid to liquid, the temperature will not change. Like if this is water, at 100 degrees Celsius, the water will just start changing to a vapor state. Still we are heating it. More of the water will change to the gaseous state. We are heating it, but we'll find a temperature is not changing. It remains 100 degrees Celsius. Though we are heating it, but temperature is not increasing here. The temperature of water becomes constant here, even if heating is continued. So where does this heat go? The answer lies in the next term, that is latent heat of vaporization. Latent means hidden. Heat of vaporization. Suppose these are the particles of liquid. They are so away from each other, like here, this is the liquid state. There are weak forces of attraction between the particles. So when we heat it, when we are giving heat to this liquid, these forces are breaking. Suppose this force will break, this particle will move away. Now this much of distance is there. When these particles are away like this, that means from the liquid they will go away, they are free to move, and now they will change to which state? Gaseous state. So the temperature at which these particles are changing to the gaseous state, that temperature is known as boiling point. For water it is 100 degrees Celsius. Now after this we have to still heat it to change these liquid particles also to gaseous state, so that the forces between these also should break and these also should move away from each other. So this heat that we are giving, that is not increasing the temperature of this liquid, that remains 100 only. So where that heat goes, that heat is not increasing the temperature of these particles. This heat is used to break up the forces between these particles. That is why temperature is not increasing. So in thermometer the reading remains 100 only. It's hidden. That is why this extra heat that we give to change whole of the liquid to the gaseous state at boiling point is called latent heat of vaporization. This heat that we give, that is called latent heat of vaporization. So definition of latent heat of vaporization is amount of heat energy required to convert 1 kg of a liquid to vapors at its boiling point is known as latent heat of vaporization. Example, latent heat of vaporization of water is 2259 kilojoules per kg. For 1 kg of water, this much of heat we have to give to change whole of the liquid to the gaseous state, called latent heat of vaporization. So after this, moving on to the third example of change of state of gas to liquid. Change of state of gas to liquid and solid. Gas we're changing to liquid and then to the solid state. So when a gas or a vapor is cooled, when we take a gas or a vapor and it is cooled, like particles are away from each other in gaseous state. When we cool these particles, what will happen? Their kinetic energy will decrease and the movement will slow down, and now these particles will come close to each other. So a state will come when the particles will be so close that from gaseous they have changed to which state? They have changed to the liquid state. They have changed to the liquid state. And further, if we decrease the temperature of this liquid state, the particles will move further close to each other, and now this one will be in which state? This one will be in a solid state. So gas is changed to liquid by decreasing temperature, and liquid further can be changed to solid by decreasing the temperature. The change of state from gas to liquid is called condensation, and changing of liquid to the gaseous state is called vaporization. That means condensation is reverse of vaporization. So we have a gas. I'm taking ice first of all. We are changing ice to water, and water we are changing to steam. How we can change ice to water? By heating it, by increasing temperature. And water is changed to steam again by giving heat to it, that is by increasing temperature. Changing of ice to water is called which phenomenon? Changing of ice to water, that is changing of solid to the water. This is called melting. This is called melting. Changing of the water to steam, liquid to the gaseous state, is called vaporization. Now we can change the steam, gas to the water, liquid state by decreasing the temperature, by cooling it. And water to ice, that is liquid to solid state by decreasing the temperature by cooling it. This is solid state. This is liquid. And this is the gaseous state. Changing of steam to water, changing of steam to water is called condensation. This process is called condensation. Changing of the liquid to solid state is known as fusion. This is known as fusion. So we can change the state of matter, one state to the another state. We can change by changing the temperature, that is by increasing or decreasing the temperature. So this is a conclusion from this thing. Next is sublimation. Sublimation is also changing of state of matter, but in this we are changing the solid to gaseous state directly or gas to the solid state without passing through the liquid state in between. There are substances which on heating directly from solid change to gaseous state, and on cooling from gaseous state directly they change to the solid state. There is no liquid state in between. Examples of these substances are camphor, iodine, naphthalene, ammonium chloride. These are some substances which shows sublimation phenomenon. They show which phenomenon? Sublimation phenomenon, that is directly on heating from solid they change to gaseous state, or when we are cooling them from gaseous they change to the solid state. Experiment. To demonstrate sublimation of ammonium chloride, to demonstrate the sublimation of ammonium chloride, in this case we are taking a china dish. This we are keeping on our tripod stand. This is a wire gauze. We have to use a wire gauze for heating, and under this we have a tripod stand. So china dish we are keeping on a tripod stand. In this china dish we are taking ammonium chloride. We are taking ammonium chloride, and over this we are putting up a inverted funnel. On this china dish we are keeping an inverted funnel, and plug the stem of this funnel with cotton. This we have to close with a cotton, and now we have to heat this china dish using a burner. So when we heat this solid ammonium chloride, all these are solid particles of ammonium chloride, they will start changing to the vapor state. They will not melt to change to liquid state. Instead, from solid directly they are changing to the vapor state. And when these vapors will touch the cold walls of this funnel, they will condense again and they will solidify and they will stick to the sides of this funnel. So on heating, solid directly changes to the vapor state, and on cooling is vapors directly will change to the solid state. So our observation is ammonium chloride on heating directly changes to vapors, and vapors on coming in contact with colder sides of the funnel will condense to the solid form, and they get deposited here in the form of white powder because ammonium chloride is white in color. So this experiment explains that some substances they show sublimation, like ammonium chloride shows sublimation.